Hello and welcome to Notes on Parts of Similar Triangles. If you have the textbook, it's section 7.5. Otherwise, we're just calling it chapter 5 and naming each section. Okay, so let's just do a little refresher here. If two triangles are similar, then a scale factor is going to exist between the two triangles. So if a triangle is 3 times bigger, it would be a 1 to 3 scale factor, or it could be 4 to 7. It doesn't have to be, to 1. And then, so anything that can be measured with a ruler would also follow the scale factor. So let's say I have the two triangles, their altitudes, and just as, like I said, a refresher, altitude is the segment from a vertex, and it has to be perpendicular to the opposite side. So every single triangle has 3 altitudes. I'm going to draw just one. An altitude could be outside of a triangle, it's the height. So this would be the altitude. Angle bisectors are segments that start at the vertex and then they have to split the angle in half. So let's say I drew one right here. I'm going to try to, that's not too good. If I had notability, I could draw this a lot better. But this angle would be congruent to this one, so this green segment is an angle bisector. A median is a segment that starts at the vertex and then it goes to the middle of the opposite side, the midpoint. So if I measured this and I said, oh, those two segments are congruent, this green segment here would be a median. And then perimeters obviously is the distance around the triangle. Regardless of what kind of triangle it is, it would be the distance around is going to follow the same scale factor. So that's important. A lot of kids forget that part when we're assessing. They forget that the perimeters have the exact same scale factor. Okay, so let's take a look at our first example here. We have triangle LJK is similar to triangle SQR. We are going to find the value of x. So I see here that we have x occupies this spot. It corresponds to 5 of the red triangle. Then we have 2 other segments that we need to have both segments have to have some sort of value. We have 12 and we have 8. I do also want you to pay attention when you start these problems. Look and see if LJK is drawn this way. This is the orientation of the blue triangle. Does it follow this order of SQR? Bottom left, up and around to the bottom right. Yes, it does follow that order. That's why then I could just very easily look between one triangle and the other, and I don't have to think, okay, is this flipped, reversed, reflected? It's following the exact same order, so I know that I'm good to go. So I could write x over 5, because x corresponds to 5, equals, and then if I started with the blue triangle in the numerator and put x, I have to start with the blue triangle in the numerator and put 12 over 8. I have to be consistent. That is key. I could have written this x over 12, so blue triangle to blue triangle, and then I have to follow that same order. So if I went this section that is a piece of the side, I would go same thing here. And by the way, this is a median. I could tell because this gets split in half, this side, and then over here, this side also gets split in half. But, sorry, I got off track here. X over 12 would equal 5 over 8. And so you may be saying, oh, those proportions are different, but they're really not. Here, if I do cross products, I'm going to get 8x equals 5 times 12 is 60. Notice how I would get that exact same thing here. I would get 8x equals 60. So now I'm going to go ahead and solve it. Divide by 8. 8 does not go evenly into 60, so I would take my fraction, reduce it. If I don't have a calculator, I'm like, okay, I know 2 goes into both of these. And then I see this could be reduced even further because 2 goes into there as well. Or I could have, divided by 4. Or I could have used my calculator and math frac it. Right, next thing we're going to learn here is the angle bisector theorem. And this says an angle bisector, which in this picture is drawn the black segment. I know that this is the angle bisector because this is trying to show that angle got split in half. And what it does is it's going to split the opposite side, meaning this one, that's the opposite side, into 2 segments that are proportional to the lengths of the other 2 sides. So B and D are the other 2 sides. So here's what happens. C, choose my highlighter. C over D is going to equal A over B. Again, I could have written this many different ways. There's many equivalent proportions that could have been written. I could have written, for example, B over D. But if I wrote B over D, that's going to go A over C. Always look at my cross products. A times D, A times D. B times C, B times C. I could have written C over A. If I go C over A, I have to be consistent with my pattern. It would be D over B. And hopefully you see that the cross products are still the same. So again, don't get too hung up on trying to memorize like it has to be these letters in this triangle. As long as you're consistent, your proportions can be written many different ways. One way that I can't do it, for example, is ever write B over C. Because B and C are not only not in the same triangle, but they're not corresponding. Corresponding doesn't really work here so much, but they don't kind of go together, if you know what I mean. I'm kind of like crisscrossing. You can't do that. Okay, so in this problem, we're going to find x. Now, I know that this is an angle bisector because, sorry, let me just pick my color right here. It's showing that the angle is split. So now I know this side to the chunk down here is going to equal this piece over this piece down here. So when I write my proportion, I could write 15 over x equals 9 over 6. Now, one thing I cannot do is to rewrite these as two similar triangles. The purple part and the red part, I can't do that. They don't really have corresponding parts. That's why I said in the previous slide, I said, oh, it's not really corresponding, but because they're not, you can't write these as two separate triangles and make them face the same direction and have them be corresponding in that way, if that makes sense. I could clarify in class tomorrow or the next day or whenever I see you. Okay, so cross products. 9 times x is going to equal 15 times 6, which is 90. X is going to equal 10. Okay? Again, I could have written this a different way. I could have written x over 6. So if I go x to 6, left bottom to right bottom, I have to go left side to right side. Cross products would be the same. I could go 15 to 9. There's many ways I could write these. 15 to 9 would equal, so because I went 15 left side to right side, I would go left bottom to right bottom. And that would equal x over 6. Again, just looking, these cross products are identical. So as long as I'm consistent, I can write these proportions many, many, many different ways. One thing I couldn't do is compare like x to 9 or 6 and 15. Those don't go together ever. Example 3 here, we want to find the value of x. So again, we are given a big triangle, and I see that what we have is an angle bisector because we have these arcs that are shown to be congruent. So therefore, I know that the sides become proportional with the like cut up third side, I guess you would call it. And so 6 over x is going to equal 14 over, we don't have a length for segment TS. So you would think, oh, maybe I could just write TS right here. But notice here then, we would have two unknown values, so we can't write that. So notice, and hopefully you did notice this, we are given this entire length is x. This piece took up, that entire length is 18, and then the little piece, cutie, took up x of it. So we have to rewrite TS in terms of 18 and x. So I always say, okay, let's pretend x is 5. How long would TS be? Well, if the whole thing's 18 and TQ is 5, TS would be 13. What if x was 7? Then TS would be 11. What if x was 10? TS would be 8. So hopefully you're getting the hang of it here. What we're doing is we're taking the entire length 18 and subtracting away x. So that's what's going to go in this denominator, 18 minus x. And again, I could have labeled this a little bit differently or set up my proportion differently. I could have said 14 over 6. That would be fine. But if I did 14 over 6, I would have to do 18 minus x over x, and so on and so forth. As long as you follow the pattern, it is good. Okay, so let's cross multiply. 14x is going to equal 6 times the entire denominator of 18 minus x. Don't just do 16 or 6 times 18. you have to do 6 times that entire denominator. So I will get 14x equals 108 minus 6x. Let's add 6x to both sides. So when I add 6x to 14x, I get 20x equals 10.8. Just kidding, 108. I'm already dividing in my head. Now let's divide by 20, and I get x is equal to 27 over 5 once I reduce x. How I did that, if you didn't have a calculator, 108 divided by 20, I see 2 goes into both. This would be 54 over 10. 2 goes into both, 27 over 5. If you don't divide by 4 initially, or you could have initially divided by 4. But in either case, you would get 27 over 5. If you have your calculator, 108 divided by 20, math frac, you will get 27/5. Okay, that's 5.4 if I have it as a decimal. Because it's a decimal that terminates, that's actually exact. So if I wrote 5.4, I'd be good to go. Last problem here is example number 4. We're going to find JU. And we're given that triangle JUM is similar to triangle ROP. So this is actually not an angle bisector problem. It's just similar triangles. So what I always notice, or try to take notice of, is are these written or drawn with the same orientation? So like JUM. So I started at the bottom left, up and over the hill. And is that the same orientation as this one? Yes, it is. If not, I would redraw them. Because now that I know that they're drawn the exact same orientation, this goes with this, and this altitude, I know it's an altitude because it's dropped from the vertex perpendicular to the opposite side, goes with the other altitude. So I don't even have to think that much about it. I just could use my eyes and say, okay, 2x plus 1 over x plus 4 is going to equal 40 over 25. Again, I didn't have to do it this way. I could have said 2x plus 1 over 40, but then I have to follow that same order for the bottom smaller triangle. I would say x plus 4 over 25. It's up to you. I could say 25 over 40. That would equal x plus 4 over 2x plus 1. You know, many different ways. Now, one thing you may notice once I drew this or wrote this proportion is 40 over 25 could be simplified. I'm going to go ahead and reduce it because I'm going to have to cross multiply, and the smaller the numbers, the better for me, because I could just do it a lot faster. So what goes into 40 and 25? 5 does, and I would get 8 over 5. Right? Now when I cross multiply, I have to make sure that I multiply everything. So it's going to be 8 times the whole quantity, x plus 4, is going to equal 5 times the entire quantity, 2x plus 1. We're going to distribute on the left, distribute on the right. And now we're just going to solve this problem algebraically. I'm going to subtract 8x from both sides. So 10x minus 8x is 2x plus 5. Subtract 5 from both sides. 32 minus 5 is 27 equals 2x. Divide both sides by 2. And you could write your answer as 27 halves or 13.5 because that terminates. That's a decimal that ends. It is exact, so 13.5 is fine as an answer. And now just go back and make sure I answered the question. They wanted me to find JU. This notation, capital letter, nothing over it means the length of JU. So I'm going to plug in here. JU is going to equal 2 times 27 halves plus 1. 2 times 27 halves is like 2 over 1 times 27 halves. The 2's cancel each other out. You're left with 27 plus 1. That is 28. For safe measure, I could plug it in here as well. So I would get for that segment, 13.5 plus 4 would be 17.5. So what I could do to check is set up a proportion. Take this side, JU, 28, over this side, 17.5, and see if it is proportional to the altitude for the top triangle over the altitude of the bottom triangle. How I would do this in my calculator, I'm going to type in 28 plus or times 25 is 700. Does this equal 17.5 times 400 or 40? Whoops, I typed it in wrong. And I get 700. So this shows me that I did find the correct value of x, which was 13.5, and then when I plugged it in correctly and got 28 for JU. All right, so that's it. The next time we see each other, we're going to do parts of similar triangles, classwork, in class, and just an FYI, I'm close friends with 25 letters of the alphabet. I don't know why. All right, have a great day. See you later. Bye.